All right, in this problem, we want to know how many seats there are in the bleachers at high school. High school. It's a very unique name, high school. It says that there are 50 seats in the first row, 52 seats in the second row, and 54 seats in the third row, and so on. There are 25 rows in the bleachers. How many total seats are there? Okay, so uh, like with all of these kinds of problems, what we need to do is identify what kind of sequence this is. So we can do that by writing the terms. So 50, and then 52, and then 53, or sorry, 54, and then it just gives us, it keeps going, dot, dot, dot. And so with this amount of information, what we have is the difference is it's 2. We're adding 2 to every time. Or the common difference between each problem is 2. If you take one term and subtract the previous term from that, you will get what's known as a common difference. In this case, it'd be 2. So we have D is equal to 2. Okay, we also have that A sub 1 is equal to 50. And what we're being asked to find is a sum of what would then be a finite arithmetic series. So 50 plus 52 plus 54 plus dot 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 plus something. And that something that we're going to have at the end there is the last term. And in order to find the last term, we need to first generate an equation that gives us a way to find that last term. So there's a general term of an arithmetic series is given by a sub n is equal to a sub 1 plus the quantity n minus 1 times the common difference d. And so if we plug all this stuff in for this problem, what we'll get is that, well, first of all, we know that there's 25 seats, but for now we don't need that right now. Well, we do need it, but let's find the general term first. A sub n is equal to a sub 1, which is 50, plus n minus 1, so we're just going to leave n minus 1 because we assume we don't know n, times 2. So a sub n would equal to, and this is going to be just 48 plus 2n. Okay, so 48 plus 2n. Now, we wanted to know a sub 25. We're going to need to know how many seats there are in that 25th row. So 48 times, not times, 48 plus 2 times 25, which is 50. It's going to be 98. There could be 98 seats in that 25th row. Now, the formula for the sum of an arithmetic series, which is what we have here, so effectively this would be 98 back here, right? The formula for the sum of an arithmetic series is S sub n is equal to the number of terms in this series times quantity a sub 1 plus a sub n divided by 2. And so for this one, the number of terms is 25. Okay, the first term was 50. The last term was 98. 98, and we're going to divide that by 2. And I don't know what that is. Let me turn on my trusty calculator. 50 plus 98 times 25 divided by 2. There are 1,850 seats in the bleachers. That's it. All right, this next problem is an example of like a ramping up type problem. So Grace wants to train for cross-country season during the summer so as not to overheat. She decides to run 2 miles one day, 2.2 miles the next day, 2.4 miles the day after that, and so on. She has a goal to run 155 miles to train for the season. For how many days in the summer does she need to run? Okay, this is a little tricky. So let's look at what we have. We are given a sub 1. A sub 1 is 2. It doesn't take much to see that the common difference, this is an arithmetic series where the common difference is 0.2. Now, what we don't know is like how far she will run on her final day of training, and we also don't know like how many days she'll have to run for. That's what we want to know. So we're gonna like I don't really know how to do this. Let's see if we can figure it out. First of all, we know that one of the formulas we're going to use, because this is going to be the sum of an arithmetic series, is the sum of this arithmetic series is equal to the number of terms times a sub 1 plus a sub n divided by 2. So in this case, we don't have a sub n, and we don't have n, but we do have s sub n. So s sub n is 155. So the things we don't know then are, n and a sub n. But we do have a way to find a sub n in terms of a sub 1. So what I mean by that is, from the previous problem, like we have this formula, a sub n is equal to a sub 1 plus the quantity n minus 1 times the common difference d. So let's figure out what a sub n is then in terms of like a sub 1. In terms of, we already know a sub 1. So we basically have a sub n in terms of n, the general term. So a sub n is going to equal a sub 1, which is 2, plus n, which is 0.2, minus 1. No, sorry, n is not 0.2, n is n. I'm sorry. N is n. Minus 1 times the common difference, 0.2. There's your 0.2. Okay, so this is going to equal 2 plus 0.2n minus 0.2. Or it's going to equal 0.2n plus 1.8. Nope, yes, 1.8. Okay, so that's what a sub n is equal to. Okay, so now I have a sub n, and I still don't have n, but I do have s sub n. So let's write this in terms of everything we know. Okay, so we know 155 is going to equal n, we don't know n, times a sub 1, which was 2, plus a sub n, which is this whole thing right here, so 0.2n plus 1.8, divided by 2. Okay, all right, we're getting somewhere here. So let's see, 2, we can do this. We can do some math. So let's factor out, let's actually get rid of this 2 by factoring out a 2 out of the top stuff. So we'll rewrite this as 155 is equal to 2n, we're factoring the 2 out of the parentheses, 1 plus 0.1n plus 0.9 divided by 2. Okay, these 2's can go away. And then we have, let's see, so what we'll have now, after we do some more math, is 155, let's just rewrite, 155 times n times 1 plus 0.9 is 1.9 plus 0.1n. Okay, we have this. All right, so let's distribute the n. So 155 is equal to 1.9n plus 0.1n squared. Okay, I don't like these decimals. So let's move the 155 over. 0 is equal to 0.1n squared. I'm also rearranging this in descending order of degree, plus 1.9n minus 155. Now I don't like these decimals, so I'm going to multiply this whole thing by 10 to get rid of the decimals. So what we're going to have then is a quadratic where 0 is equal to n squared plus 19n minus 1,550. Okay, so can we factor this? So two numbers have to multiply together to be 1,550 and add together to be 19, 50 and 31. Because 50 times 30 is 1,500, and then add another 50, it's 1,550. 50 minus 31 is 19. So it's this. It's going to be, this would factor this. This is equal to n squared plus 50n. I wrote 50n, it didn't show up. Plus 50n minus 31n minus 1550. Factor out from the first term's n. We have n plus 50. Okay, from the second term we factor out a negative 31. We're left with n plus 50. So this factors to be n minus 31 times n plus 50. And so 0 is equal to this stuff. So zero product property says that n minus 31 could be 0, or n minus 50 could be 0, plus 50 could be 0. So that means n is either 31 or maybe it's negative 50. Now it can't be negative 50 because you can't train for negative 50 days. If you could, oh my god, I would be in such good shape. That'd be great. So the answer then is 31. So Grace needs to train. Grace needs to train for 31 days. That's it. So that was a pretty tricky problem, involved the quadratic there, but nothing we couldn't really manage. So that's it. That's about all the kind of applications problems you'll see primarily for sequences and series. There's a close relationship between sequences and series and like simple interest, compound interest also, but they're not the same thing. Like if you put money into an account and it grows compound interest, like compounds annually or whatever, that number you get from the compound interest formula is the amount of money you have at the end, but it's not like a sum of all the different years of money that you have. It's a little bit different, but they're related. So that's it. Hopefully these videos help clear up some of this stuff for you, and yeah, thank you for watching.